Here we have a problem where we can factor the top. So we'll go ahead and do that first. The bottom can't be factored. So for all these kind of rational expression problems, the only thing to do would be to just factor. So factor what you can. So let's factor the numerator. Bottom we can't do anything with right now. All right, so we're looking for numbers that multiply to make negative 21, but add to be a 4. All right, so that's going to be basically 3 and 7 are really the only ones that are going to work here for that. And since the middle term is positive, that means I'll put the positive with the larger number. So I'll put a plus 7 and then a minus 3. So then I get x squared, I get a plus 7 and a minus 3. That does add up to that adds up to positive 4. And negative 3 times 7 is negative 21. Okay, now if you notice here, it may look like there's nothing else we can do, but actually there is a little bit more that we can do on this particular problem. So I have x minus 3 and 3 minus x. They look almost the same, except the order is reversed. So what I'm going to do is I'm going to factor out a negative from the bottom. Okay, so the reason why I'm doing that is because I want to make it eventually turn into an x minus 3, and I can do that through factoring. So I'm not going to do anything with the top, just leave that the same. The bottom one, I'm actually going to factor out a negative 1 from the bottom. Now doing that, what will happen is 3 divided by negative 1 will be negative 3. And then negative x divided by negative 1 is plus x. So taking out the negative, we got negative 3 plus x. Now, if you rearrange those terms there, if you rearrange that inside, we have negative 1. And then inside, if you switch the order on that, that's the same thing as x minus 3. Therefore, now we see that x minus 3 matches the x minus 3 on the bottom. And now that allows us to cancel that out. So you're going to be left with x plus 7 divided by negative 1, or you could also just write it as a negative in front like this, which actually means the same thing. So whenever you see something that is being subtracted, they're the same two things. They're just reversed like that. You can always use the same strategy where you factor out a negative 1. That's going to switch the order for you and allow you to be able to go more with canceling. Let's do another one where we do something similar. Now this one is another one where, once again, we are going to factor the top like this, and the bottom, we'll just leave that alone for now. We have x and x here. You're looking for two numbers that multiply to make negative 63 and add to be a 2. 7 and 9 would be the likely choice there. And you want it to be positive 2, so we have to put the plus with the larger number. A plus there, we have a minus with the 7. We're going to do the same thing that we just did for the previous problem. Whenever you see that, we have x minus 7, 7 minus x. The same thing, except the order is reversed. We're going to do that same thing again where we factor out a negative. Now, you could actually factor a negative out of the top as well if you wanted to, but I'm just going to stick with the bottom. Because the bottom one, I'm going to factor out a negative 1, and that basically just changes the sign of both of these here. So we get negative 7, positive x. Then you're going to switch the order around on that. We have negative 1, and then negative 7 plus x is the same thing as x minus 7. Now we notice that there's x minus 7 on the top and the bottom, and that now allows us to cancel that out. And we get x plus 9 over negative 1. Or again, you can just put a negative out front like that. Now, yes, you could also multiply that through if you wanted to. And you could also have negative x minus 9 if you wanted to, but it's sufficient. You don't have to do that, though. You can just leave it in the factored form like we see here.